Hello students, good evening. Glad to meet you again. Hope all of you are well. Today I am going to start a new chapter, derivative. This derivative is indispensable part of calculus and it is called fundamental tools of calculus. This derivative or differentiation is called fundamental tools of calculus. Let's start derivative by its definition. What is actually derivative means? Derivative is the rate of change of the function with respect to the change of independent variable. So let us recollect what we are taught in function, that y is equal to fx, means y is the function of x. We are taught x is independent variable and y is dependent variable. X is independent variable, y is dependent variable. Why x is independent variable? What kind of variable is this? Suppose x is hard work. If you work hard, then what will be the output? Good result in exam. But this hard working, if you work hard, you will get good marks. And if you ignore hard work, then hardly you can get good result in exam. That means whether you will work hard or not, that depends on you. You will take decision. So you are independent. You are free enough to take decision whether you will work hard or not. So that hard work is x, independent variable. But depending on your hard work, your result will come. Okay? If you work hard, you will get good result. So I can compare this x and y in terms of input and output. X is called input, y is output. Okay? Input is hard working, input is practicing, and output is the result. Output is result. So this definition can be modified in this way, that derivative is the rate of change of output with respect to the change of input. With respect to the change of input. Now, the procedure of derivative is called differentiation. Procedure of derivative is called differentiation. Procedure of derivative is called differentiation. So the definition of derivative we have come to know, and differentiation and derivative are same. That also we are now aware. So can I got it? Hope you understood. Okay. So let's start. Now, what is the use of differentiation? Differentiation gives us what? Differentiation gives us what? By derivative, we get the slope of a tangent to the curve at any point lies on it. So derivative gives us the slope of the tangent. Now, how derivative is related to tangent? Let us take one smooth curve and 2 points we are taking on this curve, and let's join by a line. This line is called chord. Now when this Q approaches P, when Q approaches P means when Q comes closer to P, when Q comes closer to P, that is Q is tending to P. Q is tending to P. Q is tending to P, and tending tends to, you are taught in limit. Then what happens? See, suppose this point Q, suppose comes here. Then the chord will be like this. Clearly it is visible the length of the chord is reduced. If the Q changes its place and reach this position, chord will be like this. Chord will be like this, and when, see, according to this statement, when Q is about to fall on P or tends to P, that means come closer to P and nearest value to P, then the chord will tend to a tangent. That chord will become a tangent. Now, slope of the tangent you can get by the inclination of this angle. Slope of the tangent at P to the curve gives you the inclination of the line with horizontal axis. So once you get the tangent at this point, that means by definition derivative is done, or differentiation is done at this point to this curve. That means once you get the tangent at any point on the curve to any point of the curve, that means you can say on that point differentiation is done. Differentiation is done with respect to x, with respect to independent variable, change of independent variable. So that statement is described here mathematically. Means it gives the slope of the tangent. Differentiation means slope of the tangent at any point lies on the curve. That is called differentiation. In this way, on a smooth curve, if you can draw different tangents, that means on all those points you are getting, all those points you are getting the slope of the tangents. That means at all those points differentiation is done. Means the curve is differentiated on all those points. Means these points are separated. Points are differentiated means separated from the curve. This is called differentiation. This is the concept of differentiation. Hope you understood. So differentiation actually separates the point from the curve. See, the dictionary meaning differentiation means separation. So I'm rubbing this part. Now, geometrical meaning of differentiation. Geometrical meaning of derivative. So, geometrical meaning means a figure has to be drawn XY plane and take a point P and Q on this curve. You join, you will get a chord. You will get a chord. Let the position of the point is XY, means coordinate. Drop a perpendicular. This is Y component, this is X component. Let us denote the point by M. Now as per the concept of differentiation, you put increment in X, that's why Y will also be incremented. Okay, so that point P will get a new position Q, that is X plus delta X. X plus delta X, comma, Y plus delta Y. Drop a perpendicular. This Y component is Y plus delta Y. Drop a perpendicular from this point to this vertical line. So this is, I am leveling by R. As this is a rectangle, so this is also Y. This is Y plus delta Y. So this is delta Y. This is X. This is X plus delta X. So this part, X plus delta X minus X delta X, by the rule of rectangle, this is also delta X. Therefore, the slope of the chord PQ, therefore, slope of chord PQ is what? See, let this angle PQ makes with the positive direction of x-axis, that is phi. Tan phi delta y by delta x. Delta y by delta x. Now, in differentiation, we need to find the slope of tangent, not the chord. Then again, with the previous concept I had just given you, the chord, we have to make the chord a tangent. How? If possible, if Q approaches P, that means see, Q will tend to P. Okay, so you got the concept. That means Q is coming closer to P. So as per the movement of Q coming towards P, the length wideness of delta X is reduced. Wideness of delta X, width of delta X is being reduced. And when Q is about to fall on P, then delta X tends to 0. Means being reduced, once it will tend to 0. Okay, means nearest value of 0, nearest to 0. When Q tends to P and delta X tends to 0, then the chord will become a tangent. chord will become a tangent and subtends angle theta. Subtends angle theta. So when delta x tends to 0, point Q is about to fall on P. It gives the delta x tends to 0 as well as the angle phi tends to theta. So with Q approaching P, two incidents are going to occur. Delta x tends to 0, phi tends to theta. So they are synonymous to each other. Okay. Now I have just told you that tending, that term you are taught in limit. So in this equation, take limit to both sides. You take phi tends to theta to both sides. Once you get phi tends to theta, you have to see whether you are getting any finite limit or not. Yes, we are getting finite limit defined, and the value which exists. So directly I can write tan theta. But phi tends to theta actually implies delta x tends to 0 also. So instead of this, in next line I can write delta x tends to 0 while delta y by delta x tends to 0 is equal to tan theta. What does it mean? What does it give us? This is the slope of what? Slope of a line. What kind of line? It is a slope of a tangent at P to the curve y is equal to fx. Slope of a tangent at P to the curve y is equal to fx. That means differentiation is done, because this is the role of differentiation. It means the function y is equal to fx is differentiated at point P. At point P. So if the curve y is equal to fx is differentiated at point P, then I will get this result, means increment of y with respect to increment of x, where increment of x tending to 0. So that is exactly what differentiation means geometrical. Just note down at a glance. I will wrap this part. Hope you understood. Go through the theoretical part. If you get good grip on theory, then concept-based question easily you can handle. I'm So we have got what? Therefore, what result we have got? Differentiation, differentiation of y is equal to fx at the point P is limit delta x tends to 0, delta y by delta x. Now, what is the notation of differentiation? ddx. ddx of what? What you are going to differentiate? The curve. ddx of y is equal to limit delta x tends to 0, delta y by delta x. Delta y by delta x. Differentiation at P. This is called first order derivative, or first order derivative notation is f dash x. So this part is the concept of differentiation, geometrical concept of, this is first order derivative. This is the geometrical concept of differentiation. Now, from this geometrical concept, we can extract one new concept, means the definition or first principle of differentiation. What is that? We'll come to know in sooner or later. See, by the definition of differentiation, we have seen that differentiation means rate of change of, dependent variable, okay, with respect to the change of independent variable is called differentiation. Now, see here, x changes to x plus delta x. We don't know that it is incremented or decremented. Now, as y depends on x, then y also be changed to y plus delta y. So you will get a new equation in between output and input. Obviously, it is obvious even in your life also. If we hard work, or if you spend 4 hours in a day for mathematics, obviously you will get 80% marks sure in board. But if you give some increment in study, say 6 hours in a day, then that will have reflection in your result. Marks will be increased by 10%. That means, see, as input is increased, then output is also better than previous. Now the question is, how much at the end of the session you will see your result? How much change occurred in your result from the previous result? Then how will you compare the old result, old marks in maths? Suppose I am teaching maths, so I am referring the subject. The old marks in maths has to be subtracted from new marks. Okay, if old marks is lesser than new marks, that means obviously improvement or increment is done. See, we have got y plus delta y, a new equation in x. New equation, see in adequate place, new equation between output and input. So what increment in y is, what increment and what change in y is done? So old y means y is equal to fx has to be subtracted from new one. Subtract, y will get cancelled, and you will get the increment of x in terms of this x plus fx plus delta x minus fx. So the value of delta x which you have got, you place, delta y. The value of delta y means the increment in y which you have just got will be replaced here. So f dash x will become limit delta x tends to 0. Instead of delta y, you put f x plus delta x minus fx by delta x. F dash x, if limit delta x tends to 0, f x plus delta x minus fx by delta x. That is nothing but f dash x. Just go through and note down, then I will explain. Hope you understood. I'm rubbing now. So we have got f dash x, that is ddx of y. Here you must remember ddx is an operator. Okay, don't cut it like this. It is an operator, ddx. With respect to x, you are differentiating. Okay, you are separating. Now dy dx, f dash x, that is limit delta x tends to 0, x plus delta x minus fx by delta x we have just got. Now to and compact representation, simple representation, okay, I am letting the width delta x is equal to h. Okay, now put here limit h tends to 0 f x plus h minus fx by h, that is f dash x. This is called definition or differentiation, first principle of differentiation, first principle of derivative or differentiation. F dash x limit h tends to 0 fx plus h minus fx by h. Okay, this is called first principle. Note down this important property. See, this is called definition of derivative. So from definition, all the rules, standard formulas of differentiation are come. Okay, so can I rub it? Now I will show you the use or the application of first principle in one sum, one concept building sum. So in a concept builder, I will show you the application of this first order derivative described by first principle. I'm rubbing now. See, one sum is given. Let a function is defined by f x plus y, fx into fy, where xy are both variable belongs to real number. Okay, must remember, must observe the condition. Now this condition has to be, and x and y must be, you remember x and y are variable. See, xy real, f0 not equal to 0, f5 is equal to 2 given, f dash 0 4 given, you are told to find f dash 5. See, f5 is given, f dash 0 is given, f dash 5 you are told to find. Now you have to take the help of first principle. So as a side note, you write that. Unless and until you get the grip on the subject, you write first principle as side note, that f dash x limit h tends to 0 fx plus h minus fx by h, fx plus h minus fx by h. So here f dash x is defined by this first principle, but here f dash instead of x 5 given, means 5 will play the role of x. So you start with that concept, means f dash 5 here follow the definition of derivative or first principle. Here x is nothing but 5, f 5 plus h minus f5. Okay, so we could reach up to this stage. The main part is written. Now the problem, how can I split this? Any clue is given in the question? Yes. If two variables are in additive form, then here the function is defined by fx into fy. Here in place of x, what is given? 5. In place of y, h. So if x plus y is equal to fx into fy, you do one thing. Take the value 5, put in place of x, and plug the value h, put in place of y. Then 5 plus h, 5 plus h will be f5 into fh. f5 into fh. Limit h tends to 0, f5 fh minus f5. 5h. Now we are getting the glimpse of hope. Okay, see here h tends to 0 given, so h is the variable, so this part will be considered as constant term. So you have done limit, that constant part will be taken common and will be brought out of the limit. Therefore f dash 5 will be f5 into limit h tends to 0 fh minus 1 by h. What next? Any other clue given? See, 1, there is no such value to which I can relate 1 in this context. But there is a clue f0 not equal to 0. Why f0 is given? Then we have nothing but to put 0 in place of x and y. We have nothing but to put 0 in place of x and y both. You see the outcome, f0 plus 0, because x and y variable, not constant, not a fixed value. So I can put any value according to my will. Actually, this is not according to my will, according to the sum. The sum demands 0 and 0 in place of x and y. So f0 into f0. So f0 is equal to f0 square. Now, bring all the terms in one side. You take f0 square minus f0 is equal to 0. See, inadequate place. So I am just rubbing this part. We have already taken, I think. So I can take f0 common. What will remain in the bracket? f0 minus 1. So product of two terms 0 means either this 0 or this 0. But this thing not equal to 0 mentioned in the question as f0 not equal to 0. Therefore, f0 minus 1 must be 0. So f0 is 1. So instead of this 1, you can put f0 without any hesitation. Okay, let's put. So f dash 5, f5 limit h tends to 0, if instead of h, 0 plus h minus f0 by h. See, if the formula is what? If x plus h minus fx by h limit h tends to 0 is f dash x. So in place of x, if you put 0, if you replace x by 0, so this x also be replaced by 0 and you will get f dash 0. See exactly what expression we have got here. It is actually relating to this formula. Here x, here 0. So f5 into f dash 0. What should be the next step? Nothing, because other parts are given here. F dash 0 is also given, f5 is also given. So f5 is 2, f dash 0 is 4, answer is 8. So this is a good example, good application of first principle. So according to the hour of need, we will go through so many examples like this. This is beginning. Okay, this is the beginning of the session. So in later, according to the course, we will choose this type of concept based mentor level sums, okay, to clear our confusion over this chapter, means the first principle. See, in application of formulas, hardly you can get any tough thing, because here in case of application of formula direct, that if I can bring that that form which can relate to that formula directly, I can use. But here the concept builder, in first principle you will get the mentor or concept level sum. Okay, so hope you understood. Let me wrap now. Now I just told you all standard formula of differentiation are inherited from first principle. I will not show you all, but at least the one formula, first formula, okay, of your textbook or any joint table book, let's discuss using first principle. Say y is equal to fx, that is x to the power n. How to get the differentiation? How to get the differentiation of fx using the first principle? Find ddx of y, or differentiation of y with respect to x using first principle. See, fx is given this fx x to the power n, which implies, if I replace x by x plus h, this implies x plus h whole to the power n. X plus h whole to the power n. Now, f dash x means what? Limit h tends to 0 if x plus h minus fx by h. Now, fx plus h is what? Just now we got x plus h whole to the power n, and fx already given x to the power n. Here base variable or constant. Okay. Now h tends to 0 means the term related to h will be considered as variable. So x, not variable, fixed, constant. So my job will be to bring the term regarding x will out of the limit. So by force I am taking x to the power n common. Though from this bracket, this term x to the power n cannot be taken common because two different terms are there. One is the expression of x, and another is h. But see, somehow I have to take x to the power n common and put it out of the limit. X to the power n I have taken common, but this term did not have x to the power n as an isolated term. Mix up x plus h whole to the power n by x to the power n minus 1 by h. So what I will do with this x to the power n will be put out of the limit. X to the power n. What will remain in the bracket? See, by the laws of exponent, see, this term has power n and this term has also power n. So I can club them together and considering the whole power n. X plus h by x whole to the power n minus 1 by h. That gives us what? Limit h tends to 0. X by x is 1. h by x whole to the power n minus 1 by h. So, which formula does it refer? Can you revisit the past? You are taught this thing in limit. Just I am reminding you, limit x tends to a, x to the power n minus a to the power n by x minus a. See, how can you comprehend? See, this is the variable, this is the power, minus something is given. But problem is that here h tends to 0. The variable is h, but here h by x given. So, and in denominator again h. So denominator's h has to be expressed in terms of h by x. So you bring x and to balance multiply by x. Okay. Now what I will do with this x? One extra x has come in the sum. X has no role. This x has no role. This x has role. That's why I had to introduce, and to balance I have to multiply. This x, like x to the power n, will be brought out of the limit. So in next line I can write from here, I'm shifting here, f dash x is equal to limit h tends to 0, sorry, x to the power n by x, limit h tends to 0, 1 plus h by x whole to the power n minus 1 h by x. Now here you see the formula x to the power n, that means the variable is x in numerator and denominator. But here in place of x, 1 plus h by x. But here in numerator 1 plus h by x. Here in denominator only h by x. So that 1 plus h by x has to be brought in the denominator. So f dash x, x to the power n by x, x to the power n minus 1, limit, see, f dash x has become what? X to the power n minus 1. Okay, limit. Okay, you see, h tends to 0 means what? H tends to 0 means h by x tends to 0. Okay, because x not equal to 0. We know. So limit h by x tends to 0, 1 plus h by x whole to the power n, only 1 is given. To bring the term, instead of 1, I can write 1 to the power n. By, instead of h by x, you write 1 plus h by x minus 1. Hope you understood. Now, as h by x tends to 0, therefore 1 by h by x tends to 1, and let 1 plus h by x is equal to z. So z tends to 1. See, inadequate place. So 1 plus h by x is equal to z. So as 1 plus h by x tends to 1, therefore I can write z tends to 1. So in next line, x to the power n minus 1, limit. See, I can add 1 to both sides. Z tends to 1, z to the power n, 1 to the power n by z minus 1. Now easily I can compare this to this general standard form of limit. So x to the power n minus 1, x to the power n minus 1 into, what is the formula? N a to the power n minus 1, n 1 to the power n minus 1. So 1 to the power n minus 1 is 1. So n x to the power n minus 1. So by first principle, we have got differentiation of x to the power n is nothing but n x to the power n minus 1. Okay, this is the standard formula of differentiation we have got using the first principle. Hope you understood. I'm rubbing now. Okay. In this way, we will learn the standard formula of differentiation. Learn the standard formula of differentiation. First formula we have got y is equal to x to the power n, base variable power constant, ddx of y n x to the power n minus 1. This highlighted part is considered as formula. And all formulas related to differentiation, the fundamental basic formula actually, all formulas actually are being inherited from first principle. I have shown you one. You try other formulas to be derived from the first principle by your own. In the same manner, if y is equal to e to the power mx, then ddx of y m e to the power mx. Must remember m belongs to real number, not complex number. Y is equal to log x to the base e. Then ddx of y 1 by x. Must remember x must be greater than 0. Okay. Then see base variable power constant, then I got this result. Now base constant power variable ddx of y a to the power x log a to the base e. So you have to learn this formula. Y is equal to sine mx, and here a cannot be 0. Okay, a cannot be 0. Must remember sine mx, m is real number. So ddx of y m cos mx, y is equal to cos mx, ddx of y minus m sin mx. Always remember that differentiation of constant term is always 0. Differentiation of constant term is always 0. So if you get any differentiation of a curve is equal to 0, that means it has to be considered the curve was constant. Now if you get y in terms of x, y as a function of x with coefficient c, then you differentiate, just c will be brought out. Yes, this concept you got even in limit. This constant term will be brought out. Y is equal to tan mx, where m belongs to real number. ddx of y m square mx. Y is equal to cot mx, ddx of y minus m sin square mx. Y is equal to sec mx, or in all case m has to be considered real. ddx of y m sec mx, and y is equal to cosec mx, ddx of y minus m cosec mx cot mx. So these are considered as formulas in which you have to learn and memorize. Okay. So I'm rubbing this part. if you get two functions in difference form or additive form, say y is equal to u plus minus v, then if you differentiate it, you will get ddx of u plus minus v. Now split ddx of u plus minus ddx of v. If you get product of two functions, then ddx of y will be what? See, one has to be fixed, other has to be differentiated. U dv dx, v du dx. And if you get the division form u by v, then ddx of y, v du dx, u dv dx by v square. So today we have got what we just got down. I hope all these formulas are known to you. Still, the you have to make a different formula chart, because in differentiation, in board level exam, the application of formulas will come only. In joint entrance level, the sum can be chosen from first principle also, but in board, direct use of formulas. So formulas you have to learn. You like or dislike, you have to learn. So we have just started differentiation today. We have got the concept of definition. We have got the role of differentiation, means separating the point from the curve or getting the slope of a tangent at any point to a curve. We got the geometrical interpretation of differentiation, and we got definition or first principle of differentiation. And we have come to know all standard formula are proved or inherited from first principle only. First one, that x to the power a1 n, I have shown you. Other you can try at home. So no more today. Okay, we have gone through few topics, but one thing must be remembered: in differentiation, pursuing differentiation, before pursuing differentiation, we have to keep one thing in mind: whether the function is differentiable or not. Differentiable or not. And another thing will plow in our mind, that a differentiable function must be continuous. So before pursuing the differentiation, one indispensable part is continuity and differentiability. Okay, and that really put the student in the conceptual field, differentiability. Even differentiability you can examine using graph also. You have to know how to draw different types of graph. Okay, so next day we will discuss the theoretical part, conceptual part, concept builders part, that continuity and differentiability. There are so many things in continuity. Okay, there is wonderful concept of differentiability. Okay, that will reel back the past concept of the past event. Okay, so for today's class, the topic which is covered is, okay, you go through. Next day we will start with the unfathomable concept of the continuity and differentiability. Okay, till then, goodbye, stay safe, stay at home. and next meet will be the best meet for us. Okay.